What we're going to be working on now is solving quadratic inequalities with one variable. This is different from what we've been working with because we've been graphing with two variables. But let's look at what I mean. For example, the inequality x squared plus 32 is greater than or equal to 12x. Now that only has one variable, x's, instead of x's and y's, so the steps are going to be a little bit different. The first thing that we're going to do to be able to solve these inequalities is we're going to replace the inequality symbol with an equal sign. Then we're going to solve, and what we're going to end up with when we replace that inequality with an equal sign is a quadratic equation. So let's look at that. X squared plus 32 is greater than, or, whoop, I forgot to replace it, is equal to 12x. Now that is a quadratic equation. So we're going to solve the quadratic equation that results. And we've used several different methods to solve these quadratic equations. The methods we've used are factoring, solved by factoring. We have solved by the quadratic formula. We have solved by the square root method at times. And we have solved by completing the square. If you remember from the unit that we were solving quadratic equations, you'll remember that factoring and square root method only work sometimes, but the quadratic formula and completing the square method will always work. So let's go ahead and solve this quadratic equation. In order to solve this, I'm going to go ahead and get this into standard form. So I'll subtract my 12x to the other side. So I get x squared minus 12x plus 32 equals 0. Now this one happens to jump out at me that we could solve it by factoring, because I can just see the combination that's going to work. I know my first spots have to be x and x. My last spots have to multiply to give me 32. I know both signs have to be the same, and they both have to be negative, so minus and minus. And I'm looking for my outside and inside terms to add to negative 12. So x minus 4 times x minus 8 is going to give me that. I haven't solved it yet though. So to solve, I need to use the zero product property and set each of these factors equal to 0. Remember the zero product property? Anytime you have things multiplied together and the result is 0, that means one or the other thing had to equal 0. And then go ahead and solve those equations. So I get x equals 4 or x equals 8. Okay, that is step 1. Step 2, I'm going to use those values to set up intervals on a number line. Now, my number line is going to go from negative infinity to positive infinity. And my values that I solved for need to go in order from left to right. And remember that the left end was negative infinity to the right end, which was positive infinity. If my inequality was less than or greater than, I'm going to use dashed dividers and I'll use parentheses when I set up my intervals. But if my original inequality was less than, equal to, or greater than or equal to, I will use solid dividers, and I will use a square bracket at those numbers. I'll show you what I mean by that. With our example, our two values were 4 and 8, and my original inequality was greater than or equal to. So I'm just going to rewrite my problem here. X squared plus 32 greater than or equal to 12x. So when I make my number line, I have negative infinity at this end, positive infinity at this end, and my dividers will be at 4 and 8. So 4 will go with a solid dot because it was equal to, 8 with a solid dot because it's equal to. If they were less than or greater than, I will use open circles. So maybe I'll put open circles up here and closed circles right there. And then my dividers will be solid. So when I draw my dividers down, they're going to be solid. And then I'm going to list my intervals like we did for domain or increasing and decreasing and positive and negative when we were graphing quadratic equations. So I'm going to go left to right, and each of these little regions is going to be a separate interval. So in my first interval, it goes from negative infinity to 4. Now negative infinity always gets a parenthesis, and the 4 this time gets a bracket because it was a less than equal to, greater than equal to problem. So it gets a bracket. And then this section goes from 4 to 8, and they both get brackets. And the last section goes from 8 with a bracket to positive infinity with a parenthesis. And that's step 2. In step 3, I'm going to be using that little graph that I just made, and I will be testing a value from each interval. So there's a couple of guidelines there. You cannot use, so do not use the divider values. So there are 2 numbers I cannot use in my problem. I cannot use 4 and I cannot use 8. The second guideline is that you should test by substituting the x value that you chose into the original inequality. And then what you're going to find is that you will either get a true statement or a false statement. So a true result means that the interval you tested is part of the solution. If you get a false result, that means the interval tested is not in the solution. So let's see how that works. I need to pick a value from my number line that's in between negative infinity and 4. 0 works well. Usually I'll write my tested value up at the top. And then I'm going to substitute 0 in for x. So I'll have 0 squared plus 32 is greater than or equal to 12 times 0. That ends up giving me 32 is greater than or equal to 0. Now that is a true statement, so I will write T for true. Then I'm going to go to my next interval, and I need to test a value between 4 and 8. I might pick 6. You might pick 5 or 6.29 or whatever you decide. And I'll plug that into my original, so I'll have 6 squared plus 32 is greater than or equal to 12 times 6. So that is 36 plus 32 is greater than or equal to 12 times 6 is 72. So I'm adding those. 68 is greater than or equal to 72. And that is false, so I'll put an F for false. And then my third interval, maybe I pick 10. So I'll substitute that in. 10 squared plus 32 is greater than or equal to 12 times 10. 10 squared is 100, so 100 plus 32 is greater than or equal to 120. 132 greater than or equal to 120. That is true as well. So I know the true results mean that my interval that I tested in is part of the solution. My false result means that it's not a part of the solution. So whenever I get a false result, I just kind of X out that entire section, and whenever I get a true result, I usually circle that entire section. And then the solution that I want to report is the intervals that I tested in. So the solution to my inequality is the interval from negative infinity to 4. And then remember, we use a U union to represent that we skipped over a section. So negative infinity to 4 or 8 to infinity. And that would be what you call the answer.